Welcome to Anything Maths. If you find this video helpful, give it a thumb up. The topic for discussion is surds. What is a surd? I'm not going to give you a technical definition because that is not going to help. Rather, what I'm going to do is to give you some few examples of what a surd is, and based on those examples, you will come to a better understanding of what a surd is. So let's look at some examples. Root 2 from your calculator will give you 1.4142, and it goes on. Root 3 will give you 1.732, and it goes on. The cubic root of 4 will give you 1.587, and it goes on. So this is the most important point. If you take a root of a number and you don't get a whole number, we can see that these are not whole numbers. Then it means that root of that number is a surd. So as you see, root 2 is a surd because the answer is not a whole number. Root 3 is a surd because the answer is not a whole number. The cubic root of 4 is a surd because the answer is not a whole number. So now that we know what surds are, let's look at examples that are not surds. The square root of 4 will give us a whole number. So it means square root of 4 is not a surd. The square root of 16 will give us 4, a whole number. So the square root of 16 is not a surd. The cubic root of 27 is 3. It gives us a whole number. So the cubic root of 27 is not a surd. Now we can have other roots like 4 root, 5th root. As far as this video is concerned and the syllables for GCSEs, we're going to look at just the second root or the square root surds. That's all we're going to look at in this video. Now, because we are just looking at square root surds, there's something that I want to bring to your attention that will help you in manipulation of surds. What do I mean? Adding, subtracting, and doing rationalization. This is what I want you to know. If you squared 1, what do you get? You get 1. Now, if you take the square root of 1, you get 1. So it means 1 is not a surd. It's obvious. If you take 2 and square it, you get 4. If you take the square root of 4, what do you get? 2. It's not a surd. 3 squared, get 9. Square root of 9, 3. Now you can see a pattern is developing, isn't it? Now if we go maybe up to 12 square, we're going to 144. When you take the square root of 144, you know what the answer will be, isn't it? 12. Now this is so important, and the importance of this will become more apparent as you start adding, subtracting, and doing some kind of rationalization with surds. So please take note I want you to know all the square numbers between 1 and 20. We're going to learn some few rules of surds. So let's look at the rule 1, number 1. The square root of AB, which could also be written as A times B, and we can split them. That's what the rule says. It's going to be A times what? Root B. How do we apply it? Let's look at some examples. Example 1. The square root of 12. Now this is where the idea of the square numbers actually comes in. Now we can write 12 in so many ways. We can say 6 times 2 will give us 12, isn't it? And 4 times 3 also will give us 12. But as far as this particular example is concerned, the second is very important because we can see that it's a square number there. 4 times 3, 4 is a square number. So we will prefer that one over 6 times 2. Okay. And as a result, we can write root 12 as 4 times 3. And we can also write it as 4 times root 3. 2 times root 3. And eventually you're going to get 2 root 3. Okay. If we had used the 6 times 2, we're not going to get that. The second example. 75. Now, I think 15 times 5 will give us 75, isn't it? Yeah. And 20 times 3 will also give us 75. Now, immediately we can see that 25 is a square number. So that's the best one to use. So we can say 25 times 3 is the same as 25 root 25 times root 3. And these will be 5 times root 3, which will then give us 5 root 3. Nice and easy. Great. The second rule is the square root of A over B. Also can be written as the square root of A over the square root of B. Example. Example 1. The square root of 49 all over 81 is become the square root of 49 all over the square root of 81. And you see that 49 is a square number, 7 squared, so it's 7. And 81 is a square number, 9 squared, so it's 9. Nice and easy. So the next question is the square root of 3 over 121 is the same as the square root of 3 all over the square root of 121. Now the square root of 3 is a set, so there's nothing we can do. Leave it that way. The square root of 121 is a square number, which is 11. Correct. We're going to look at how to add sets and do subtraction as well. Now, how do we add sets? Let's look at a general example. So, p root x plus q root x. You can see that root x is common to both of them. And that's the reason why you can add them. If they have different sets, you need to do adjustment to them before you can add them. Some example will help you to understand this better. But the general formula is this. You're going to have p plus q root x. Let's look at example to demonstrate this. So examples, it's always 2 root 3 plus 6 root 3. Applying the rules, we add because they all have root 3. It's a matter of adding the numbers 6 root 3 here. And you're going to get 8 root 3. Second example. 4 root t plus root t. Now root t, there's a 1 root t, but we don't write it because it's meaningless. We know that it's only 1, so we don't write it. So it becomes 4 plus 1 root t, which becomes 5 root t. Okay. The third example, if you have 4 plus root 2 plus 6 root 2, what do we do? Now the 4 is standing alone, so there's nothing to add to, so we maintain the 4. So we put our 4 here, and we say plus 1 plus 6 root 2. And this will give us 4 plus 7 root 2. Example 4. 10 root 5 plus root 125. This is interesting, isn't it? Now we can see they have different roots. First of all, we want to see whether we can write root 125 in terms of root 5. If we are able to do that, then we can successfully do the addition. However, if we are not able to do that, then there's nothing we can do about it. So let's have a look. We can write 25 times 5 as 125. So it means we can do something. Because 25 is a square, and we take the square root, it's going to be 5. But the other one is going to be a third. So it's going to work. So it means this actually becomes 10 root 5 plus the square root of 25 times 5. The next step will be 10 root 5 plus root 25 times root 5. 10 root 5 plus 5 times root 5. The next step will be 10 root 5 plus 5 root 5. What do we have? 15 plus 5 root 5. And the answer will be 15 root 5. We're going to look at subtraction. How to subtract. P root x minus q root x. Root x is still common, so it's much easier to do P minus q. Nice and easy. With some examples to help. First example, we got 4 root 7 minus 2 root 7. Now they all have root 7, so there's no problem. All that you have to do is to apply 4 minus 2 root 7. Then you get 2 root 7. Okay. The second example is 3 root y minus 13 root y. They all have the same root, same set, so 13, 3 minus 13 root y. Be careful, 3 minus 13 is negative 10 root y. Okay. Third example. We have 6 plus 2 root 3 minus 10 root 3. How do you do this? Now 6 has no root 3 attached to it, so there's nothing we can do. We will just maintain it. So we write our 6 down. However, we just put those who are the root 3 together. So it's going to be 2 minus 10. This. And we're going to have 6 minus 8 root 3. This brings an end to the first part of the Surds video. If you found this video helpful, please give it a thumb up and subscribe. Why? Because soon the second part will be out.